Hello everyone. In this lecture, we will understand what is rotational motion and the analogous elements of the translation and rotational motion. So rotational motion, it is the motion about the fixed axis, and here the force get replaced by the torque. Force was in the translation motion, and here in rotational motion that force gets replaced by the torque. And torque is equal to the moment about the fixed axis, which can be written as the product of the force and the distance from the fixed axis. Likewise, the translation motion, here the rotational motion is also governed by the Newton's laws of motion. Therefore, here you can write it as sum of the torques applied on a rigid body that will be equal to the sum of the torques consumed by the different elements of the system. And these will produce what? Angular acceleration, angular velocity, and angular displacement, represented or denoted by alpha, omega, and theta respectively. So the rotational motion, it is characterized by angular acceleration, angular velocity, and angular displacement. Whereas in translation motion, you were having only it as acceleration, velocity, and displacement, but here it is angular. Now the dominant elements of this rotational motion are the inertia, spring constant, spring K, and friction B. Inertia is similar to the mass. So mass was in the translation motion, which was denoted by capital M. Here it is replaced by inertia, that is analogous to mass is the inertia J. And spring constant, spring and the friction, these will remain same. Inertia, it is nothing but the moment of inertia, that is the property of the system which stores the kinetic energy in the rotational systems. Likewise, the mass in the translation was it was a property of the system which stores the kinetic energy in the translational systems. So here it is inertia which will store the kinetic energy in the rotational system, and it doesn't have the power to store the potential energy, because of which there will be no change in displacement. So here the opposing torque, it is directly proportional to the angular acceleration omega. Now if you remove this proportionality sign and we'll take the proportionality constant J, therefore torque due to the inertia, it is equal to J into d square theta of t by dt square. That is nothing but the angular acceleration. So angular acceleration is double differentiation of the displacement. When you take the Laplace of this, you will get t of s, that is equal to j into s square theta of s. And these are the analogous elements of the translation motion and the rotational motion. In translation motion, you are having mass m, so it gets replaced by the inertia j in the rotational motion, whereas the friction and spring remains same in both the motions. Here force gets replaced by torque, then displacement x gets replaced by angular displacement theta, and the velocity v, it gets replaced by angular velocity omega, which is given by d theta by dt, and here in translation motion it is dx by dt. Similarly here acceleration in translation motion, it gets replaced by the angular acceleration. So acceleration is double differentiation of the displacement x, and angular acceleration is alpha, that is equal to double differentiation of the angular displacement theta. So these are the analogous elements of the translation motion and the rotational motion. Thank you.